Hi, I'm Yoram from Tikal Knowledge. I'm not a DevOps mentor yet, and I'm not going to show you exactly how to become one. But I'm going to show you a project I'm working on and how I use my skills to lead it. The project is very simple. It's to take a monolith project and make microservices out of it. In the meantime, to switch from SVN to Git. This is something we do a lot in Tikal, and this project is not an exception of it. And the main thing that the people face with the new project is the fear from the change, what they don't know about it, and what they don't know. And this is what the main obstacle I'm facing with those kind of projects. And this project it's a corporate, and they don't have a real CI/CD. The versioning is bad. The method of work, they work agile, but not so good. And this is something I need to deal also. And another thing is that they have paying customers that the version that installed on their stack of the customers are something they need to have working at the same time with the new version. And the hybrid mode is another obstacle to the project. So I think that automate everything is a key factor for the success of the project, and keeping the users from dealing with the versions and like the liquid software talk about is another thing that I keep in mind. And the way to achieve the project as I see it is something I call multi-layer CI/CD, which is something for another session that I can take for another time. But now I'm going to show you what the skills that I need to use for the success of the project, for leading the project. For the first thing is the experience that you bring. The much you have experience, the better you deal with the project and with people, and the way that you show them how to work, and the way that you work and they see how you work uh, helps in the success of the project. And also be a troubleshooter. I mean, every time you deal with a problem, you must know how to debug, how to fix the problem, and be flexible to what the needs of the customer. Learn the situation, and all the time you work with many tasks, not on one task. So you must do context switch all the time, uh, give service to other teams, and you need to do it all the time. And the way to do it also is to document everything, build procedures. Everything should notify about problems along the way, and create routines that people will work with. And when you talk to people, just do it in their language. I mean, even if you know that you know better how to do things, and you use terms that they don't understand, it won't help. Do it in their language, and feel like in the same level with them all the time. And you must inspire them for the trust and for leading the change, because they have to deal with the change. Remember it all the time. So you must be a role model for them and know everything you do. And be brave, because things happen along the way, and you must go forward with the project and meet all the expectations they expect from you. Um, and people think you must think out of the box all the time. I think that in this kind of project, you must adjust the box to you, to what you think, because you lead the way, and they don't know all the time what is the way, and you lead the way. So do it for them. And when you leave the project, and you must leave something that they will remember. They must use it, because if you don't leave something, they're going to use what the point of the project. So share everything, and give them something to remember. And then along the way, you have people that oppose the project. So because they fear they are conservative, or they think about another way to do it. So if you make them your biggest fan of the project, everything will work for you and for the project sake. And if you meet all those 5 factors of being a mentor, you're in the correct way. And this is what I want to be. I want to be a DevOps mentor. So thank you for listening.
Today, we'll be talking about how the Artifactory team at Capital One deploys, automates, and integrates Artifactory user plugins at an enterprise level. First of all, I would like to introduce myself. My name is Alec Patel, and I have been on the Artifactory team here at Capital One for about 11 months. I would also like to introduce my coworker, Hank Hudgens, who has helped me create this material that I'll be sharing with you all today. Hank and myself will be around during and after the presentation to answer any questions that you may have if time permits. The Q&A session will be handled via chat, so feel free to engage in any questions that may come up, and we'll try to answer them as best as we can. Let's start with the agenda, where I'll go over the overview and pipeline process. First of all, we have unit tests. These are short and simple tests to ensure the behavior of the plugin in question is behaving as intended. Next, we have the security scan stage, where we verify that industry and enterprise security standards are met. Third, we have the actual deployment of the user plugin into the cluster and some modifications to assist in logging. After successful deployment, we move on to functionality test stage. Here, we want to make sure the behavior of the plugin is correct in the newly deployed environment. And finally, we have performance testing. This is the longest stage in the pipeline in terms of duration. This is a very important stage as it verifies that plugin code is not affecting the overall application as a whole. Now that we have an overview, let's dive a little deeper into each one of these stages. Let's circle back to our first stage, unit tests. Here, we actually bring up the same version of Artifactory that we will be deploying in a Docker container. We wait for the Artifactory application to start up in this Docker container, and shortly after, we deploy the plugins to the appropriate directory. Once the plugins deploy, we execute all the tests. And if all the tests pass, great, we move on. If not, the pipeline will actually fail. Short and simple, let's move on to the next stage. Our security scan stage actually has 2 elements. First off, we have a code quality and security scan. Here we will ensure our unit tests are properly cover all blocks of code and identify any possible bugs, security vulnerabilities, or code smells. Next off, we have a source code analysis. This second scan will highlight any possible static code vulnerabilities, as well as identify any open source software vulnerabilities and expose licenses for open source components. Like the previous stage, if this stage fails to meet a set quality gate, the entire pipeline will fail. On to the actual deployment stage, which is split up into 3 different tasks. For this stage, we leverage the configuration management tool called Chef. First, we have the deployment, which consists of a Chef recipe code block that moves all the plugins from our development directory into the appropriate directory on the Artifactory's primary node and only on the primary node. Once the plugins are deployed, their permissions are also appropriately modified. Next, we have another Chef recipe code block that actually modifies Artifactory's logback file, which allows us to aggregate user plugin logs into one file. We also keep a backup of this initial logback file, just in case we need it in the future. Lastly, we have a validation process where we use the Chef inspect framework to ensure that plugins are in the right directory and the logback file is correctly modified. This pipeline stage will also fail if we For example, a plugin is not deployed properly or one of the lines in the logback file is missing. Now, after the plugins are deployed and the Artifactory application is up and fully functional as a whole, we have our integration tests, or also known as functionality tests. Like I mentioned earlier, this is just some extra validation that we have in place to make sure that the deployed plugins are actually behaving correctly in their new environment. For the sake of time, all these tests run in parallel and follow a common theme that if they fail, so does the pipeline. And last but not least, we have performance tests. These tests are crucial to ensure there are no negative performance impacts to the application as a whole. They run in parallel for 15 minutes for each plugin, making continuous requests that execute plugin code. And we do this solely to ensure that users are not experiencing any latency when deploying new plugins. Thank you guys for attending the lightning talk, and we hope you've gained some valuable insight on how we deploy and test these Artifactory user plugins at an enterprise level. Feel free to ask any questions. Thank you.
Hi, everybody. My name is Tim Smith. I'm Senior Manager of Enterprise DevOps at Rogers Communications. It's a Canadian telecom. I'm the IT owner of a lot of DevOps tooling that IT uses, including things like GitHub Enterprise, Urban Code Build, Urban Code Deploy, SonarQube, and of course, JFrog Artifactory and X-Ray. Before I get started, I really wanted to thank you all for taking the time to join us at SwampUp. JFrog has done a great job to quickly put together a great few days of training and speaker topics from a wide range of people and places and companies like Microsoft, Capital One, Launchables. Kosuke Kawaguchi is here. I've seen him a few times at Jenkins World, where I got this pretty sweet t-shirt. He's great to listen to. And of course, JFrog's developers, engineers, and little old me. So since I only have about 4-ish minutes, I won't get too deep into our transition, as I tend to ramble about DevOps. But what I would like to focus on is utilizing support from your vendors. We have sure needed it on our journey, and man, since you pay for it, you may as well use it. I'm first going to start with the great support I've received from a vendor connecting into Artifactory. And I'm going to start with IBM HCL Urban Code. I've worked closely with them for a few years now. I have bi-weekly calls with Urban Code to keep on top of new trends, open tickets, their status, or if there's not too much going on, sometimes where the good restaurants are in Cleveland, where Urban Code is based, and I can't wait to visit there one day. Hi guys, I know you're watching. We recently did an upgrade of our Urban Code deploy system. We hadn't upgraded in some time. We were well overdue. There were some new features that we wanted to take advantage of. Urban Code also released a great new product called Velocity recently. It's for value stream management and reporting and insights and maintenance planning. So it's a great tool if you have a chance to quickly check it out. But we couldn't connect to it with our older versions, so we had to upgrade. In our conversations back and forth with Urban Code, they said, look, you should open a case with IBM. It will come to us. We'll assign an expert who can be at the ready if you have a problem. And sure enough, we did. And we're glad that we opened that case. When we did our upgrade of server and agents, our agents stopped talking to Artifactory. We did some digging and we found out there were some major changes in the Groovy code, and that's what stopped the communication. So we downgraded our agents, and the communication started working to Artifactory, and life went on. But afterwards, I was able to keep on top of our case. We had a patch deployed to us shortly afterwards, and we were able to get our agents re-upgraded and communicating with Artifactory at that higher level. So Urban Code's communication has always been great, but it's always been that back and forth I've really appreciated, and I really appreciate the great support that they've given me. Now, of course, here I am at a JFrog event, so of course I need to talk about JFrog and the great support they gave me when we had an upgrade issue during when we were upgrading Artifactory. We had version 6.9, and of course we wanted to move to the fancy new platform version of 7.3. So in preparing for this and preparing for an HA build, our infra team took a clone of our current on-prem Linux server. Unfortunately, they didn't turn off some of the services on that new server. So when they ran a yum update, it updated the new server, but it also connected to the database and upgraded the database. So our old 6.9 server couldn't talk to the new upgraded database. So I quickly reached out to Sarah Van Leeuwen, who is our account rep. Hi, Sarah. And with the subject line of emergency, emergency, well, we quickly got a ticket open. Sarah took that ticket, quickly escalated it. She got a great support engineer by the name of David Shin. David jumped on our call within a few minutes. He stayed with us for well over 8 hours. He helped us upgrade our old server from 6.9 to 6.10 and then further to 7.3 due to a known issue when upgrading from below 6.10. So if I can give you any advice, please check out JFrog's Confluence page. There's some great support pieces on there, and make sure you reach out to your account rep if you are planning on upgrading. But David helped us upgrading some drivers, pointing out the right files to update. We had a join key mismatch error. It was an absolute mess, but David stuck through it. He helped get us going. He joined again the next day just to help us finish off some of the upgrade pieces. So without that support, we would have been in trouble. So use that support. Keep in touch with your account reps. They are awesome people who really want to help and really want to make sure you're successful with the product. So thank you for listening to me today. I really hope you enjoy the rest of your time here at Swamp Up. Thanks for joining. Bye-bye.
Welcome to How to Deploy Artifactory via an operator in OPENSHIFT. First, I would like to thank everybody for joining this lightning session. My name is John Peterson, Senior Engineer in the Partner Engineering Team here at JFrog, and the lead for the OPENSHIFT operators. Whether you're a beginner to an OPENSHIFT Pro, we will cover soup to nuts in this session how to deploy Artifactory via the OPENSHIFT Operator Hub into your existing cluster. First, we will cover all the groundwork for setup prior to installation, how to use the OPENSHIFT Operator Hub for installation, and finally, how to verify and check your installation of Artifactory into OPENSHIFT. Let's dive in. JFrog has launched 2 operators into the OPENSHIFT Operator Hub. Administrative users can now install the JFrog Artifactory operator as well as the X-Ray operator into OPENSHIFT. There are a few prerequisites that we will cover to help guide you through this process seamlessly. To install Artifactory as an operator, there's 3 major prerequisites that we will need to cover. First, the SSL cert we will need to install into our OPENSHIFT cluster. This can be done by creating a TLS secret through the OC command line tool. Once you have your TLS key and certificate saved into the secret, take note of the secret's name, as we will apply this value later when we create Artifactory. Next, we will need to ensure that we have Enterprise and Enterprise Plus licenses that can be applied. Note we will need to have at least 1 license per Artifactory node. Last, we need to ensure that we have an external database available. Artifactory supports a number of databases, and any of these can be used. However, if you plan to install X-Ray, we recommend that you use the Postgres database, as this component can then be leveraged by both Artifactory and X-Ray. Now that we're ready, let's hop over into the OPENSHIFT cluster to utilize the Operator Hub. Now that we have the Operator Hub open, let's do a quick search for JFrog, and you'll notice both operators appear on screen. Go ahead and click on the JFrog Artifactory Enterprise operator to begin the installation process. Now that we are installing the JFrog Artifactory operator, we need to select some options, such as the namespace that we would like to deploy the operator into. Note, this is only for the operator and not for the instances of JFrog Artifactory Enterprise that we will create later. Once we have chosen our namespace, click on Subscribe to install the new operator into OPENSHIFT. At this point, we have now installed the JFrog Artifactory Enterprise operator into our OPENSHIFT cluster, but we have not created any instances of Artifactory Enterprise. What the operator provides for us is a new provided API called Artifactory HA. Through this particular provided API, we are able to create new instances of Artifactory Enterprise. Once we have clicked on Create, a new instance of Artifactory Enterprise will be presented with this option screen, where we will need to supply our prerequisites that we have gathered prior to installation. Fill in all values with override, which are namely the database configuration and the TLS secret name that we created before. Once we have updated all values with override, our new configurations, go ahead and click on Create to launch a new instance of Artifactory Enterprise. We are now able to utilize the OC command line tool to find our instances that were created by the Artifactory Enterprise operator. Once our pods have finished deploying, we can use the external IP of the Nginx load balancer to access our Artifactory instances. We will then need to complete the onboarding wizard to finish our installation of Artifactory Enterprise into OpenShift. At this point, we have now successfully deployed Artifactory Enterprise into OpenShift. Thank you for attending How to Deploy Artifactory via an Operator into OpenShift. You can now deploy Artifactory via an operator with ease directly into OpenShift. These slides are available online at the link shown above. Our OpenShift operators are also open source and available at the link shown above to GitHub. In addition, please visit our blog post that has step-by-step instructions on how to deploy Artifactory into OpenShift via the Operator Hub. Thank you and have a great day.
Hello, I'd like to talk about Artifactory in connection with Terraform utility today. My name is George Gal. I live in Moscow, Russia. I am working for the top #1 retailer in Russia called X5. You can refer me to DevOps because sometimes production is burned down, nothing is working, and my task is to go and repair it. So, why should we use Terraform? Because it is a cool toolkit. It's a very powerful. It can spin up different types of environments, test or production environment in rapid manner, and in the same rapid manner, it can destroy them. So one must be very careful when using it. First plan and then apply. It's a universal tool for managing infrastructure. It not only supports such entities like virtual machines, but also different kinds like firewalls, networks, policies. Through support of different providers, Terraform can support creating of such resources like Grafana dashboards, GitLab repositories, keys, and many more. With the help of Terraform utility, one can build a multi-cloud environment. Of course, it's not an easy task because building blocks are very different, and you need to build your own solution over Terraform manifests. Terraform also forces such very good and good principles like infrastructure as a code and immutable infrastructure. What I mean, infrastructure as a code are shown in Terraform manifests, and Terraform usually not modify the existing entities, but prefer to recreate them from scratch. So, as I said, Terraform are very extendable thing with the help of providers. I show the list of them on this slide. You can see many names like Acme, GitLab, OVH, but it's a very pity there is no Artifactory. So, as I need to build different environments, I decided to write my own. There are two different types of interaction between Terraform and Artifactory, which can be implemented. The first one is backend. It's a simple storage for the Terraform state file. Terraform state file contains the current state of infrastructure and is used for modifications made by Terraform. It's developed by HashiCorp and can be downloaded via official site. Unfortunately, this backend doesn't allow such a very important feature as logging. It means that if you run multiple copies of Terraform in the same time, they will read the old Terraform state file, change it in some way, and then upload it back to Artifactory, and you will get into race condition and with probably ruined infrastructure. So the solution is simple to run Terraform only in one copy. Terraform can be can communicate with Terraform provider in well-documented RPC interface, and in its turn, Terraform provider must use HTTP API of JFrog Artifactory. It's well documented on the site of Artifactory. You may check the documentation for it. It took 2 weeks for development of the POC. I implemented only proxy repositories because we use Artifactory primarily for caching, and my task was to make the upgrades secure. So we spin up a new environment with old version, create some settings, repositories in Artifactory, and check that it works and upgrade. If everything is fine, we go to production and make the same actions on it. Also, I learned that Golang is not hard. It's a very simple language for implementing system toolings, network utilities. I recommend it for everyone to learn. When I was developing the provider, I accidentally found that it was developed also by Atlassian company. The link is below. So my work is useless in some meaning. Please use Atlassian ones, but don't be afraid of reinventing the wheel, because you get experience, and it can help to completing your tasks. So it's all. Thanks.
Hello, my name is Robert Wang with Salesforce. Thank you for joining today's lightning talk. In this talk, I'll be presenting how to use drag and drop to visualize CI/CD activities by using the Tableau. A little bit about myself. I'm responsible for build and release engineering at Einstein Platform Readiness team. Our team is responsible for build automation, source control management, and CI/CD pipelines. A background about this presentation. We have a demo user, which produces builds and artifacts. We'd like to find out the relationship between these builds and artifacts. We'd like to find the build jobs and artifacts related to this user. We'd like to find the download dependencies and deploy artifacts. This is a high-level diagram of build activities. We have the CI system in TeamCity, which build and publish artifacts to Artifactory. The build history and Artifactory logs subsequently will be sent to Tableau, where we can construct build activity stories. In order to present this demo, there's a few steps: installation, preparation, construction, and visualization. I will go over this in next demo. For installation, we simply install the Tableau desktop. In today's demo, we will go over connecting the data from Artifactory logs and TeamCity build history. Then we will use drag and drop to create build activity stories. There are other options to install Tableau Server for on-prem, or Tableau Online, which is managed by Tableau. For preparing data, we can connect the Artifactory logs and TeamCity. By default, the Tableau support many data sources. So in this demo, I just need to connect the JSON from build history and the text file from the request.log from Artifactory server. Connected data, you can see this is a typical input fields and values from request.log in Artifactory server. once data connected, I can move around the worksheet by drag and drop the fields from the left-hand side into the field. I can organize these columns and rows and color code for different data values. I also can add detail for each data point. Similarly, for TeamCity worksheet, we can carry out similar actions. So move the data fields from left-hand side here, which import from the TeamCity build history and into the worksheet. We can organize columns and rows and set the value, set the color code or details for each data point and values. Once these are ready, then we can drag and drop from the worksheets into a storyboard. So this is a Tableau desktop. In the Artifactory worksheet, you can see the values ready for moving things around. As I can move the IP address to the columns. So you can see more detail about the IP address. If you don't like that, you can also undo. So it's very convenient for using Tableau. You can drag and drop things and undo. So very forgiving and without constructing complex queries. We can perform similar activities for the TeamCity worksheet. Once worksheets are done, we can drag and drop worksheets into the story. For example, in this story point for builds, I can find out which build type I might be interested. I can say demo A, then limit all the output for demo. And artifacts, for artifacts, you can see the user name, and this is all the artifacts you get published or or download. In this particular example, I say search for Apache, then it display all the path name that match Apache. And it's also, when you mouse over, give more detail, its response code and total size for this binary. And of course, you can undo the selection. You can see other upload and download activities against the Artifactory. That's it. Thank you for watching. Hopefully you enjoy, and let me know any questions. Thank you. Talk to you soon.
Hello everyone, my name is Muktesh, and this session is about waking up in the weeds of microservices, how to diagnose your first bug. So we all know microservice architecture, we implement that, but this session is mostly to talk about what are the potential solutions we can implement to diagnose different bugs, and how to detect the problems quickly in a microservice architecture, because in most of the scenarios, we see it happens like this. So this is a famous tweet, a snapshot from Twitter, where they are talking about if there is a problem arises with microservice architecture, they are not able to detect it. It looks like a murder mystery. So let's go right in. So this is about me. I work for Adobe, and I am a contributor to 20 plus projects. And I am open source advocate, and I contribute to projects like Spinnaker, Hystrix, Contour, OpenTracing, Istio, and I present into various conferences as well. So this is my GitHub handle and Twitter handle. So probably the best way to reach out to me if you have any questions about this talk is through GitHub issue or Twitter as well. So feel free to reach out if you have any questions regarding the contents present. So let's talk about the microservice. So as we all know, microservices are a collection of different services, different small services, which do dedicated work. And mostly what happens is these services are heterogeneous in nature. There is no limitation of technology, because you can use any technology. So the core idea behind the microservice architecture is you can use any technology you want, and you can manage the life cycle of these microservices separately. So that is why they are heterogeneous in nature. Then resources are distributed. So the core idea behind microservice architecture is to distribute your computing resources. So your all the computing resources and services are distributed to different parts, and then they are not central. So then talking about the multipath, so because microservices are a collection of services, so in a system, when you implement the microservice-based architecture, a lot of back and forth communication goes on based on the functionality you are trying to implement. So it depends upon, say, for example, in a shopping cart, you can have a microservice for product check-in, you can have a microservice for ordering, you can have a microservice for shipping. So there is a lot of communication goes on back and forth, and they work perfectly. So this all looks good and dandy. This all looks fine until some problem arises. Because of different microservices acting together in a system, so what happens when a problem arises? You don't see a problem. So because there can be various sources, there can be multiple sources of the problem, so it is hard to trace where the problem is. And then this happens. So here is this snapshot is from Avengers, where Spider-Man is talking to Iron Man saying, I don't feel so good. So that is how your system talks to you. And then it doesn't know what is happening. I don't want to go until it blasts. So this is the general problem because of the nature, the way microservices architecture are implemented. These are the common problems. Now, let's talk about how we can solve these problems and what are the approaches we can take. So these slides talk about like when we develop the microservice architecture or when we are developing the microservices, we have to put a focus on operational excellence mindset as well. What does that mean is uh, you need to think through from the problem solving perspective. As a developer, we always think from the implementation perspective of a problem, but we need to think through the maintenance as well as the operational side of that as well. What will happen if the things go wrong? So one pillar of that is the logging. So the clear or the better our logging is, the better our system will perform. So uh, so first aspect is a common formatted logging. So common formatted logging is at any your logging should be uniform. You should be any person should be able to identify where the flow is going, which method it is in, what are the input output parameters and things like that. You can still have different loggers, but your logging formatting should be the common across different microservices. That way you can trace easily like what is happening. It's structured. This is a new phenomenon. So traditionally, the way logging works is we put loggers in the plain text, raw text format in the raw text file. But things have changed now. So now loggers support the JSON structure. So actually, you can log a JSON blob into your microservice. And then there are different parsers which can parse the JSON information. So it is like every logger is having a metadata associated with that also, which can help you in quickly triaging your problem. Then coming on to observability. So observability talks about giving the insight on what is going on in the system. So basically what you do is you propagate different headers and you can do the call graphs. Control switches are bounded architectural context. So microservice architecture consists of various components. So each level you need to have like feature flag, or you need to have some way of reducing the blast, controlling the blast. So when implementing the architecture, you should think about like how I can stop if something goes wrong. How can I prevent the impact? What is my alternate option? So that is where circuit breaker and feature flags help you. Well-defined SLXs. SLX stand for service level indicators and service level objectives, service level agreements. So when you are integrating with that, you should always define like what are the proper service level indicators you are going to monitor. What this will do is it will reduce the noise because you can tune your monitoring, you can tune your alerting, and you can quickly detect a problem. And you can implement a smart alerting as well. So what did we learn? So we learned loggers and information is important because you can have the structured logging. architecture consists of components. That is why you need to have control your blast radius. Call graphs should be traceable. You should always have a control on which service is calling what and where the flow is going. Service level notation should be part of design. So while designing the architecture only, you should be having focus on like different components around like how your system should behave. So I have included a couple of links, also helper links, which can help you. And that's all I had. Thank you so much. And yeah, that's it. If you have any questions, you can always reach out to me on GitHub or Twitter. That's all. Thank you.
Thank you for joining the Unified Log Analytics with the help of Splunk. I'm your presenter, John Peterson, lead engineer on the JFrog Observability Initiative, and today we're going to show you how you can leverage Splunk with JFrog's unified platform to deliver the insights to the predictive models of the future. These slides will be available immediately following this presentation. Through the use of our new Splunk-based app and through the use of various other tools in Splunk, such as the Machine Learning Toolkit, you can now deliver insights to predictions through the data that comes from the unified platform. Once you have set up the platform to deliver data to your Splunk instances, you will get a single consistent JSON format, which will be easy to mine for data scientists to deliver rapid insights that quickly lead to predictions. There will be additional SEM data, metrics data, and more to come in Q3, so stay tuned for more news on that front. Now that we've given you a taste of what's to come, let's go over what's been delivered. Today, there is the Splunk-based app, which consists of the JFrog dashboard, as well as HTTP event collector setup help. There's also the public GitHub log analytics repo, which contains configuration files for FluentD, which is the unified platform that sends logs to Splunk. Currently, the FluentD configurations are available for RT6, RT7, and X-Ray 3. In addition, we've made an easy-to-use zip installer for FluentD for customers who may have non-root-based installation paths. Let's jump into the dashboard. As you can see, this is the JFrog Unified Platform Dashboard, which contains the log volumes by hour, the log errors for Artifactory and X-Ray in the last 24 hours, the HTTP 500 errors in the last 24 hours, the response codes in the last 24 hours, the accessed images in the last 24 hours, as well as the accessed repos in the last 24 hours, the data transfers in uploads as well as downloads, and the top 10 IPs by uploads and downloads. Finally, we go into the audit section where we contain the audit actions by users, the denied actions by username, the denied logins by IP address, and the denied actions by IP address in the last 24 hours. The last two widgets in our dashboard contain the denied logins by username and IP, as well as the accepted deploys by username in the last 24 hours. Let's dive deeper into this particular widget here, which gives us the list of denied logins by username and IP. If we take the query that runs this widget and we take it into the Splunk Machine Learning Toolkit and we build a smart outlier detection report, we can quickly build a JFrog unknown denied logins report. This is one way where you can quickly use our data to build predictive models that can then enable your business. As you can see here, this is just the query that came from that dashboard widget. No, our widget is editable by everybody, so all of our queries are freely available. And you can copy and paste this query into the Smart Outlier Detection and see the data. Once you have found the data, you can click Next, and that will take you to the outlier detection. In this particular instance, I am analyzing the count field by username, and I'm detecting the outliers. And as you can see here, I have selected the top 10 groups, which in this case are usernames. And in our particular test data, it looks like these are the 10 usernames that was identified. Once I click Next, what I'm then able to do is see the model summary, but more importantly, the outlier analysis, which quickly gives me identification of which users are having denied logins What this enables the business to do in these COVID-19 times when users are working remotely is quickly identify which usernames might be getting hijacked. Thank you for joining the JFrog SwampUp Lightning session for the Unified Log Analytics with the help of Splunk. Our links are available below, which contain the slide deck, the Splunk-based app, the GitHub, as well as the blog. Thank you and have a great day.
Hi, everybody. Thank you for joining this session on securing embedded device updates with Yocto and OSTree. We are going to briefly cover how Artifactory and X-Ray can be used to improve the full DevOps lifecycle for these devices, especially around traceability and compliance. My name is Brennan Ashton, and I'm the technical lead for IoT at JFrog. First, I'd like to provide a brief introduction to Yocto and OSTree. The Yocto project is a collection of tools and metadata that enable building custom embedded Linux distributions. This can be used in conjunction with OSTree, which provides an immutable Git-like representation for operating systems and enables atomic updates. Because Yocto builds are frequently comprised of hundreds or thousands of software components that are bundled into a handful of opaque binaries, it is critical to capture traceability metadata early in the build process. By capturing this metadata, we can identify security and compliance concerns for the entire life of the release artifact. Additionally, by utilizing an atomic update system such as OSTree, we are able to bring visibility of the exact changes to a device down to the individual file level. In the next several slides, I will provide a demonstration of how we're able to do this with the JFrog platform using an actual Yocto build. The first step is collecting all the intermediary RPMs or Debian packages that are created in the build process and linking them to the resulting artifacts, including the file system image for factory programming and the OS commit for performing updates. This is done by leveraging the Yocto build history feature and using it to generate a build info file. All of these dependencies are then stored in Artifactory, generic, or RPM or Debian repositories. Here we can see the build info visualization from our build containing 310 components, everything from the Linux kernel to an SSH client, as well as the resulting 19 artifacts. By enabling X-Ray to scan the build, we can identify vulnerabilities that impact the entire system by the individual component. In this case, we've identified a high security vulnerability in OpenSSL that's impacting the build. By inspecting the violation, we can gain a further understanding of what the impact is and how it might be remediated. For this violation, upgrading OpenSSL from release F to G will resolve the issue. At this point, they update the recipe or the entire layer and create a new build. In this case, our next build will be addressing multiple other fixes in addition to this security issue. Now that our build 70 has been published to X-Ray, we're able to see the OpenSSL vulnerability has been addressed and there are no other outstanding known issues. By performing a comparison between the two builds, we can see all of the component level changes, including the version change of the OpenSSL package itself. Next, we'll take a look at how this update will impact the device firmware in a more detailed way by comparing the two OSTree update commits. Because the update to this device is being managed through OSTree, the state of the device for the given update is immutable, and we are able to see all of the changes that will take place in the file system, including add, remove, and modification operations. Here we can see multiple configuration changes that are taking place, including the addition of a new systemd service that's being started. Going forward, we'll be continuing to improve our integration with Yocto, especially around generation of build info and managing of the build artifacts themselves. Currently, this is handled by parsing build history metadata rather than natively integrating into the build process. We are also improving our metadata capture to expand X-Ray's ability to be aware of vulnerabilities that have been addressed via build patches, as well as simplifying the process of license compliance. And third, we're looking for more feedback around managing complex embedded system builds. Thank you for attending this lightning talk on securing device updates with Yocto and OS tree. Please feel free to reach out if you have any questions or comments, or you would like to learn more about how this can be integrated into your workflow. Thank you.